Hello everyone, welcome back to another video on superposition theorem. In previous video, I had explained that how to apply superposition theorem for analyzing the circuits when we have only independent sources and when we have both independent and dependent sources present in the network. In this video, I will solve three different problems which will have only independent sources. The dependent sources will be considered in the next video. If you want to know about the theoretical concept of superposition theorem, that how to apply it, then you can check the link for that video in the description box. Now let's start with the first problem. First problem is find the current through 4 ohm resistance using superposition theorem for the network. So what is the network that I am drawing over here? We have one independent voltage source of 40 volts, and we have one more independent source, but that is a current source which supplies 8 ampere current. So we have to find out the current through 4 ohm resistance. So this resistance, as we have two independent sources, 40 volt source and 8 ampere source, so we have to solve the circuit twice. Once when the voltage source is active, second time when current source is active, and then we will find out the resultant current through this 4 ohm resistance. I am considering this terminal as A, this one as B, so that we can find out the current whether it's flowing from A to B or B to A. So as we have two different sources, so we have two different cases. Case 1, when 40 volt source is active. So when 40 volt source is active, we have to redraw the circuit. 40 volt is active, so it will remain in the circuit as it is. 12 ohm resistance, then we have 5 ohm resistance, 4 ohm resistance, 3 ohm, and we need to replace this 8 ampere current source by its internal resistance, and for an ideal current source, the internal resistance is infinite, so it has to be replaced by an open circuit. Now we need to find out the current through this 4 ohm resistance. Let's say that current is denoted by I1. Now it's your choice whether you want to go with mesh analysis or you want to apply nodal analysis. But if I choose mesh analysis, then I have to write two equations, one for this mesh, second for this mesh. And if I want to apply nodal analysis, then we have just two nodes. Out of them, one has to be reference. If this one is reference, then we can assign the voltage to this node. We need to solve just one equation and then we can have the value of I1. So here I will apply nodal analysis, and after applying nodal analysis I can have the answer of I1 as V upon 7, because 4 and 3 ohm resistance, now they are in series. So it's V by 7. We need to find the answer of V. For finding V, I will apply nodal analysis. We don't know the direction of any of the current, so I am assuming all of them as outgoing currents, that is, they are leaving this node. So current through 12 ohm resistance will be V minus 40 by 12. Current through 5 ohm resistance V by 5. Then current through this 4 ohm which is in series with 3 ohm, it will be V by 7, and this should be equal to 0. So what we get from here, that V by 12 plus V by 5 plus V by 7, that is equal to 40 by 12. And when we solve it, then we will get the answer V as 7.821 volt. Now you can check these answers by your own, whether you are getting same answers or different. You can verify it by mesh analysis as well. When we use this value of V, then I1 is 7.821 by 7, that is 1.117 amperes, and it is flowing from A to B. This is what we had assumed. B minus 0 by 7, it means it is flowing away from this node A to B. This one is B and this one is A. Then we have second case, case 2. Now what is case 2? When only 8 ampere source is active. When only 8 ampere source is active. So when only 8 ampere source is active, so this 40 volt source, it has to be replaced by its internal resistance, and the internal resistance of an ideal voltage source is 0. 0 means short circuit. So we will have a short circuit in place of 40 volt source. And then we have 12 ohm resistance, 5 ohm resistance, 4 ohm, 3 ohm, and here we have 8 ampere current source. And we are interested in finding out the current through 4 ohm resistance. Now here again we have different choices. We can apply mesh analysis. If we go with mesh analysis, first mesh, second mesh, third mesh, though we get the answer of third mesh current directly, that will be, if I assign this current as I3, then it will be minus of 8 amperes. We can go with nodal analysis as well. If we go with nodal analysis, then we have three nodes. Out of them, one has to be reference. This one is reference, then we need to assign voltage to this node, voltage to this node, then we need to write two nodal equations, solve for them, and then we can find out the answer of current through this 4 ohm resistance, whether it's flowing from A to B or B to A. That will be decided by the magnitude of voltage of these two respective nodes. So it's totally an individual's choice that which method you want to adopt. But we can have one more choice, that we can apply current division rule. This circuit can be simplified to, if we just look at these two resistances, these two are in parallel. What we have over here, that 8 ampere current is coming from this side. It will get divided into two parts. Obviously, the current will flow from B to A through 4 ohm resistance. So this current is in opposite direction to what we had in previous case. And after that, it will be dividing into further two parts. So basically, how the 8 ampere current is getting divided, that is decided by this 3 ohm resistance, and the all these three resistances which are connected over here. So we can replace this by an equivalent by calculating the parallel combination of 12 and 5 ohm resistance, since they are connected in parallel. Because what we have seen, that these the current is getting divided over here. So when current is getting divided over here, it means these two are in parallel. So if we solve their parallel combination, 12 in parallel with 5, then it comes out to be 3.53. And then we have 4 ohm resistance, 3 ohm resistance, and here we have 8 ampere current source. Now it becomes quite easy to apply current division rule. We can find out the value of I2. I2 will be equal to source current, that is 8 ampere, into opposite branch resistance 3 divided by 3 plus the resistance of branch through which we are finding out the current. So it will be 4 plus 3.53, and this answer is 2.279 amperes. And here the current is flowing from B to A. So the resultant current is actually algebraic sum. Since the two currents are flowing in opposite direction, we have seen that 1.17 ampere is flowing from A to B, 2.279 is flowing from B to A. So obviously the resultant current will be from B to A. We can say it is from B to A. It will be equal to I2 minus I1. 2.279 minus 1.117. So answer is 1.162 ampere. So this is what we got by superposition theorem, because according to superposition theorem, the response through any circuit element is algebraic sum of responses when the two sources, or when the sources are acting individually. You can verify these answers by applying mesh analysis or nodal analysis as well to this circuit only. We can apply mesh analysis. We will have three different meshes. If we go with nodal analysis, we can have two nodes where we need to apply KCL. Third will be the reference. So you can have the comparison of the answer. And definitely you will get same answer, that 1.162, and that current will be flowing from B to A. Let's move to second problem to have a better understanding of superposition theorem. And now the problem is using superposition theorem, find the current through 4 ohm resistance in network shown in figure. Now let's see what is the network. Again, we have two independent sources. One is a current source, second one is a voltage source, and we have different resistances. This one is 4 ohm resistance through which we are interested in finding out the current. So again we need to solve the circuit twice. Case 1, when only 5 ampere source is active. When only 5 ampere source is active, so what we have to replace the 20-volt source by its internal resistance. The internal resistance of an ideal voltage source is 0, so it has to be replaced by short circuit. So it's 20-volt source, it has to be replaced by short circuit. As we replaced the voltage source by short circuit, we can apply circuit reduction technique. Since 5 and 6 ohm resistance, now they are in parallel. These two terminals are same, these two are same, 5 and 6 they are in parallel. So this circuit is now reduced to 5 ampere source, which is in series with 2 ohm, 6 ohm, and then we have parallel combination of 5 and 6. When we solve the parallel combination of 5 and 6, it becomes 2.73 ohm, and then in parallel we have 4 ohm resistance. So the circuit reduction has simplified the circuit to this, and now we can easily apply current division rule, and we can find out that what's the current I1 through 4 ohm resistance. So I1 will be source current, that is 5 ampere. Here we have 5 ampere current which is getting divided into two parallel paths. So 5 into opposite branch resistance. Now opposite branch is a series combination of 6 and 2.73 ohm resistance, with 6 plus 2.73 in denominator, resistance of the branch through which we are finding out current, plus opposite branch the resistance. So this will give us the value of current as 3.43 ampere, and it's flowing in downward direction I1. Now let's move on to the second case, case 2. Case 2, when 20-volt source is active. This is the second case. When 20-volt source is active, at that time the current source has to be replaced by its internal resistance. The internal resistance of current source is infinite, so it has to be replaced by open circuit. So when now 5 ampere source is replaced by open circuit, so we have a 20-volt source. So this forms one mesh, this is second mesh. So now it's again our choice that how we want to find out the current. We can find out the current by mesh analysis. We can find out the current through this 4 ohm resistance by finding out that how much the current is supplied by this 20-volt source over here, and then obviously that current will get divided into two parts, through the 6 ohm and through 6, and then which is in series with the 4 ohm resistance. I think now it will be more clear. The current supplied by this 20-volt source over here will get divided into two parts. One will be across a series combination of 6 and 4, and second is the branch having a 6 ohm resistance. So if this I want to adopt this method, then I need to find out current I over here, and then we can find I2. I2 will be equal to I into opposite branch resistance, that is 6 ohm, and in denominator we will have 6 plus 6 plus 4 10. So we need to find out the value of I. Now what will be I? I will be equal to 20 upon R equivalent. Now what is this R equivalent? This R equivalent is the equivalent resistance seen from this 20-volt source terminals. So if you want to find out equivalent resistance between these two terminals, like over here we want to find our equivalent, then we have to start from the opposite side. Then how they are connected? 6 and 4, they are in series. So that 10 ohm is in parallel with 6. So our equivalent will be 6 plus 4. They are in parallel with 10 ohm resistance. And then this is in series with 5 ohm. So this will give us actually our equivalent resistance as 8.749 ohm. So by using this value of R equivalent, I becomes 2.286 amperes. So when I is 2.286, then I2, which is equal to I into 6 divided by 6 plus 10, that is 0.857 ampere. Now that is flowing again in downward direction. So it means both the currents, one because of current source, second one because of voltage source, both are in same direction. So by superposition theorem, I4 ohm will be equal to I1 plus I2. The answer for I1 was 3.43. I2 is 0.857 ampere. So it becomes 4.29 approximately. So you can see over here I have found the current through 4 ohm resistance by current division, and for that I need to find out that what is the current supplied by this 20-volt source. You can apply mesh analysis over here to find out this current. You could have applied the nodal analysis as well. So you can apply the method which is suitable to you, but keep in mind that you need to solve the problem with minimum number of steps and minimum calculations so that we can save the time and we can avoid the chances of mistake. The chances for mistake increases when we s- choose the methods which will have more number of equations. I can show you over here that we will get same answer if we use mesh analysis. Just have a comparison of that one as well. So I can assign two currents to this mesh I1, to this mesh I2. So we'll have first mesh equation minus 20 as negative sign came first, plus 5 into I1 plus 6 into I1 minus I2 equal to 0. So our first equation will be 11I1 minus 6I2 equal to 20. This will be our first equation. Then mesh 2 equation. Let's start from the 6 ohm. 6I2 plus 4I2, then drop across the 6 ohm resistance, plus minus, plus 6 into I2 minus I1 equal to 0. So this will give us second equation as minus 6I1 plus 16I2 equal to 0. From here we will get the answer of I1 as 2.286 and I2 as 0.857 amperes. So this is same as what we found by finding out the current division rule which we had applied after finding out that what was the current supplied by 20-volt source. Now let's take one more problem, and that is the last problem of superposition theorem when we have only independent sources. Question over here is find the current through the 3 ohm resistor using superposition theorem. So firstly we have a current source, and different resistances, and here we have independent voltage source. We need to find out the current through this 3 ohm resistance. Again we have only two independent sources, so we have two different cases. Case 1, when only 5 ampere source is active. When only 5 ampere source is active, then this voltage source, it need to be replaced by its internal resistance, and that internal resistance is 0, which means short circuit. So let's replace this voltage source by short circuit. Here we have voltage source, which is replaced by short circuit. Now this short circuit is in parallel with 4 ohm resistance. So short circuit means zero resistance. 4 in parallel with 0 means equivalent is 0. So in any case, if we have any resistance which is connected in parallel with short circuit, that will get short circuited as well, in irrespective of what is the value of that resistance, whether it's 4 ohm or 100 ohm or 1000 ohm, whatever its value, if it is connected in parallel with short circuit, then it will get shorted at the same time. So this 4 ohm, it will be replaced by short circuit. The circuit is now simplified to this one. This is a circuit. This is a 5 ampere source. We need to find out the current through 3 ohm resistance. Now we don't need to go for any mesh analysis or node analysis. We have 5 ampere source that is supplying 5 ampere current. That current is getting divided into parts because we have two different branches which are connected in parallel. So we can apply current division rule. Let's say this current is denoted by I dash. So I dash will be equal to source current 5 ampere into opposite branch resistance, that is 15 ohm, and in denominator opposite branch resistance plus the resistance of the branch through which we are finding out current, 2 plus 3, so that is 5 ohm. So answer is 3.75 amperes, and that's flowing in downward direction. Second case is when only 20-volt source, only 20-volt source is active. When only 20-volt source is active, then current source has to be replaced by its internal resistance. Independent current source, that is replaced by open circuit. So let's replace it by open circuit. So now what we have, if this is terminal A and this one is B, then we have between terminal A and B we have one branch of 20 volts. Second one, in parallel with it we have 4 ohm resistance, and then in parallel we have another branch consisting of 4 resistances which are connected in series, 3 plus 2 plus 5 plus 10. It's 20 ohm resistance, and we need to find out the current through this. Since this is the polarity, this terminal is positive, this one is negative, so this will be the direction of current. So we can see that the voltage from this terminal to this terminal is actually 20 volts. We can find out the current of I, value of current I double dash as 20 divided by resistance of this branch, 3 plus 2 plus 5 plus 10. So it will be 1 ampere, and that will be flowing in upward direction. Now the two currents, they are in opposite direction. Because of 5 ampere it's in downward direction, because of 20 volts it's in upward direction. So by superposition theorem, I 3 ohm will be equal to I dash minus I double dash. Since the magnitude of I dash is more, so I have considered that as positive and I dash as negative. So 3.75 minus 1, 2.75 amperes, and this current is flowing in downward direction. You always need to keep in mind that when you find out the current by using superposition theorem, then you need to mention its direction. So in all these problems, we had found the current. We could have the problem that where we need to find out the voltage using superposition theorem. So I will consider that type of problem in the next video when we have the dependent sources as well in the circuit. I hope these three problems are enough to understand superposition theorem.